Finding a specific circuit breaker, such as the Square D MAL36400, can sometimes be challenging, but several avenues can be explored to locate one or a suitable replacement. Firstly, consider checking with local electrical supply stores. These stores often carry a wide range of circuit breakers and may have the specific model you need in stock. Even if they don't have it on hand, they might be able to order it for you or suggest a compatible alternative. Secondly, explore online retailers like Amazon or eBay. These online marketplaces can be valuable resources for finding both new and used circuit breakers. Use the specific model number MAL36400 in your search query to narrow down the results, and be sure to carefully review the product description and seller ratings before making a purchase. Thirdly, it may be beneficial to contact the manufacturer Schneider Electric directly. They can provide information on authorized distributors in your area or suggest a direct replacement model if the MAL36400 is no longer available. When searching for a replacement, it is crucial to ensure compatibility with the existing electrical system. Consider factors such as the voltage rating, amperage rating, and interrupting capacity. The voltage rating of the replacement breaker must be equal to or greater than the voltage of the circuit it will be protecting. For example, if the circuit operates at 240 volts, the replacement breaker must be rated for at least 240 volts. The amperage rating of the replacement breaker should match the amperage rating of the original breaker or the circuit's design capacity. Using a breaker with a higher amperage rating than the circuit can handle can create a fire hazard. The interrupting capacity, also known as the short circuit current rating, is the maximum amount of current the breaker can safely interrupt during a short circuit or fault condition. The interrupting capacity of the replacement breaker must be equal to or greater than the available fault current at the point of installation. This information can typically be found on the electrical panel or through a qualified electrician. In addition to these electrical characteristics, the physical size and mounting configuration of the replacement breaker must also be compatible with the existing electrical panel. Ensure that the replacement breaker fits properly into the panel and that it can be securely mounted. Consult the electrical panel's manufacturer specifications for compatible breaker types. If you are unsure about selecting a compatible replacement, it is always best to consult with a qualified electrician. They can assess your electrical system and recommend a suitable replacement breaker that meets all safety requirements. The National Electrical Code, or NEC, provides guidelines and standards for electrical installations, including the selection and installation of circuit breakers. It is important to adhere to the NEC requirements to ensure the safety and proper functioning of your electrical system. For example, NEC Section 240.6 provides standard ampere ratings for fuses and inverse time circuit breakers. NEC Section 310.15 addresses ampacity of conductors. NEC Table 310.16 provides ampacity ratings for insulated conductors rated up to 2000 volts, 60 degrees Celsius through 90 degrees Celsius, in free air. NEC Section 110.3 outlines the examination, identification, installation, and use of equipment. When working with electrical systems, always follow safety precautions to prevent electrical shock and other hazards. Firstly, always disconnect the power to the circuit before working on any electrical components. Secondly, use insulated tools and wear appropriate personal protective equipment, such as safety glasses and gloves. Thirdly, if you are not comfortable working with electricity, hire a qualified electrician to perform the work. Circuit breakers are essential safety devices that protect electrical circuits from overloads and short circuits. They are designed to trip and interrupt the flow of current when a fault condition occurs, preventing damage to equipment and reducing the risk of fire. Regular inspection and maintenance of circuit breakers are important to ensure they are functioning properly. Look for signs of damage, such as cracks, discoloration, or loose connections. Test the circuit breakers periodically to verify that they trip when overloaded. If you suspect a circuit breaker is faulty, replace it immediately with a new one of the same type and rating. Understanding the fundamentals of circuit breakers can help ensure a safe and reliable electrical system. Firstly, a circuit breaker is an electromechanical device designed to protect an electrical circuit from damage caused by overcurrent or short circuit. Secondly, its basic function is to interrupt the flow of current when a fault is detected. Thirdly, this interruption prevents overheating and potential fires. A circuit breaker typically consists of several key components. Firstly, there is a set of contacts that allow current to flow through the circuit under normal conditions. Secondly, there is a bimetallic strip or magnetic coil that senses overcurrent. Thirdly, there is a tripping mechanism that opens the contacts when a fault is detected. There are two main types of circuit breakers. Firstly, thermal circuit breakers use a bimetallic strip that bends when heated by overcurrent, triggering the tripping mechanism. Secondly, magnetic circuit breakers use an electromagnet that trips the breaker when the current exceeds a certain threshold. Circuit breakers are rated based on their voltage and amperage capacity. Firstly, the voltage rating indicates the maximum voltage the breaker can safely handle. Secondly, the amperage rating indicates the maximum current the breaker can carry without tripping. It is crucial to choose a circuit breaker with the appropriate voltage and amperage rating for the circuit it is protecting. Circuit breakers are installed in electrical panels, also known as load centers or breaker boxes. Firstly, these panels serve as a central distribution point for electrical circuits in a building. Secondly, circuit breakers are plugged into the panel and connected to the wiring of individual circuits. When a circuit breaker trips, it must be reset manually. Firstly, to reset a breaker, switch it to the off position and then back to the on position. Secondly, if the breaker trips again immediately, there is likely a persistent fault in the circuit that needs to be addressed. Never attempt to bypass or disable a circuit breaker, as this can create a serious safety hazard. Circuit breakers are designed to protect against different types of electrical faults. Firstly, overloads occur when a circuit draws more current than it is designed to handle. Secondly, short circuits occur when there is a direct connection between two conductors with different voltage potentials. Thirdly, ground faults occur when current leaks to ground due to damaged insulation or faulty equipment. Circuit breakers are also classified based on their interrupting capacity, which is the maximum amount of current the breaker can safely interrupt during a short circuit. The interrupting capacity must be high enough to handle the potential fault current at the point of installation. Regular maintenance of circuit breakers is essential to ensure their proper operation. Firstly, inspect the breakers for any signs of damage or corrosion. Secondly, test the breakers periodically to verify that they trip when overloaded. Thirdly, tighten any loose connections to prevent overheating. When replacing a circuit breaker, it is crucial to select a compatible replacement with the same voltage, amperage, and interrupting capacity ratings. Firstly, refer to the electrical panel's manufacturer specifications for recommended breaker types. Secondly, if you are unsure about selecting a replacement, consult with a qualified electrician. Understanding the principles of circuit breaker operation and maintenance can help ensure a safe and reliable electrical system. Firstly, always follow safety precautions when working with electricity. Secondly, if you are not comfortable performing electrical work, hire a qualified electrician. Thirdly, regular inspection and maintenance of circuit breakers can prevent electrical hazards and protect your property. The specific model number, MAL36400, indicates a particular type of circuit breaker manufactured by Square D, now a brand of Schneider Electric. These molded case circuit breakers are designed for specific applications and have defined electrical characteristics. Firstly, the MAL designation may refer to a specific frame size or series within the Square D product line. Secondly, the 36400 number likely indicates its amperage rating and other performance characteristics. To find detailed specifications and technical data for the MAL 36400, consult Schneider Electric's product catalogs or website. This information will include voltage ratings, interrupting capacity, trip curves, and other relevant parameters. If you cannot find the exact MAL 36400 model, consider searching for alternative Square D circuit breakers with similar specifications. Consult with an electrician or electrical engineer to ensure that the replacement breaker is suitable for your application. They can assess your electrical system requirements and recommend a compatible substitute. When sourcing circuit breakers, be cautious of counterfeit or substandard products. Purchase breakers only from reputable suppliers to ensure they meet industry standards and safety requirements. Using counterfeit or substandard breakers can create a serious safety hazard and may not provide adequate protection for your electrical system. Always verify that the breakers you purchase are certified by recognized testing laboratories, such as Underwriters Laboratories or UL. These certifications indicate that the breakers have been tested and meet established safety standards. In addition to circuit breakers, other protective devices are used in electrical systems such as fuses and ground fault circuit interrupters, or GFCIs. Fuses are one-time devices that melt and interrupt the circuit when an overcurrent occurs. GFCIs are designed to protect against ground faults, which can be particularly dangerous. These devices detect small imbalances in current and quickly trip the circuit to prevent electrical shock. Understanding the different types of protective devices and their applications can help ensure a safe and reliable electrical system. When designing or modifying an electrical system, it is essential to consult with qualified professionals. Electrical engineers and electricians can provide guidance on selecting the appropriate protective devices, sizing conductors, and ensuring compliance with electrical codes. Proper electrical design and installation are crucial for preventing electrical hazards and ensuring the long-term reliability of your electrical system. Always prioritize safety when working with electricity and seek professional assistance when needed.